Okay, just a run through on equating real and imaginary parts using Cartesian and polar form. Okay, so first of all, part A, just express this in real and imaginary form. So we're going to express it in the form of A plus IB. So in order to do that, we need to realise it. So we multiply by like its difference of 2 squares. So on the bottom, this is equivalent to having A plus B, A minus B, so it ends up being A squared minus B squared. So it'll just be 1 squared minus I squared. And on the top, let's just expand it. We'll need the long way. 1 times 1 is 1. 1 times minus I is minus I. I root 3 times 1 is plus I root 3. And I root 3 times minus I root 3 is minus I squared root 3. Okay, so now we're just going to, first of all, square that I out there. So that'll give you a plus root 3. So you got 1 minus I plus I root 3, and then that'll be minus 1 root 3 all over 1 minus 1 squared. So just squaring out both of the I squareds. Okay, then if we look at the next thing, what we want to do now is I'm just going to put the real parts together, and I'm going to put the imaginary parts together. So I'm just going to put 1, and that's going to be minus, that'll be plus root 3. Then I go plus, and I'm going to rearrange it so you go I root 3 minus I. So I just keep that positive in the middle. So the first one's just going to be, there's the 1 plus root 3, and the other one, the I root 3 minus I. And that's all going to be over 1 plus 1, which is 2. Okay, so if you look at this, that's going to be 1 plus root 3 plus I, which will be root 3 minus 1. So I'm just factorising out that I, so I get it in the correct form. And I'm just going to split it, so it is actually in the form of A plus IB. Like this. So we now have our real and we have our imaginary part. So there's our real part and our imaginary part. Okay, now part B, we're going to do the same thing, but we're actually going to put this into, sorry, I meant to use that colour pen. We're going to put the same thing, but we're going to do it using mod arg form. So the first one, if you plot 1 plus I root 3, that's in that quadrant. So R is going to be the square root of 1 squared plus root 3 squared, which is root 4 or 2. Okay, and then it's going to be cis, so we have to find that angle. So when you think about in that quadrant there, what will that be? The y value is root 3, 1. So we go tan theta is root 3 on 1. So that means that tan theta is going to be 60, which is pi on 3. Okay, so that's pi on 3. So that's going to be cis pi on 3. Now doing the bottom one, the 1 plus I, that's going to be in that quadrant again. And tan theta there is going to be 1 on 1. So theta is going to be tan the minus 1 of 1, which is pi on 4 in that quadrant. The modulus is just going to be the square root of 1 squared plus 1 squared, which is root 2. So it's root 2 cis pi on 4. Okay, so now what we have to do is we have to equate just simplify the modulus, and then with the arguments, because it is division, we need to subtract. So 2 on root 2, if I just simplify that by rationalising it, you get 2 root 2 on root 2 times root 2 is 2. The 2's cancel and you just get root 2. And the cis pi on 3, so we've got the cis pi on 3, and we are going to minus the pi on 4. So that's going to be cis 4 pi minus 3 pi on 12, which is cis 4 minus 3 is pi on 12. So that means that it will equal the 2 on root 2 simplified to root 2. That's what that is over there. And then the other one, the argument went to cis pi on 12. So I'll just write that down there. So cis pi on 12. So we've now done 2 parts to this question. First of all, we've written the first one in mod arg form. And then we've done that one. So we've written the first one in a plus ib in Cartesian form. The second one in mod arg form. And now what we're going to do is use the first part and the second part to help evaluate the exact value of cos pi on 12. Okay, so that's C. So our steps in doing this is, first of all, you get the complex number and you put it in the form of a plus ib. The second thing you do is you get the complex number, you put in the form of I cis theta. And now, because these two things are equal, what we're going to do is we're going to make r cis theta equals a plus ib. And that means that cis theta, if I divide by the r, would be a over r plus ib over r. Can you see that's just fitting actually the triangle if you plotted the complex number in it? Like if you plotted the complex number and that was a and b, and that was r, then you're just finding a in terms of theta and r, and b in terms of theta and r. So the next step that you do is you take the cis theta and you write it as I cos theta plus I sine theta, and you make that equal the other side, which is a on r plus I b on r, and then you can conclude that therefore the real part, which is cos theta, will be equal to the real part on the other side, and the imaginary part, which is sine theta, is equal to the imaginary part on the other side. So that's a on r, and so that's the first two. And then the second one, we can say sine theta, the imaginary part, would equal to b on r, which gives you that one. Okay, so if I'm applying that here, we have a real and we have an imaginary part, and they're going to be equal. So that means that root 2 cis pi on 12 would have to equal 1 plus root 3 on 2 plus I root 3 minus 1 on 2. So root 2 cos pi on 12 plus I sine pi on 12 equals 1 plus root 3 on 2 plus I root 3 minus 1 on 2. So I now take that root 2 and I'm going to put it and divide it on the denominator, so over the other side, because the opposite to times in is division. So cos pi on 12 plus I sine pi on 12 equals 1 plus root 3 on 2 root 2 plus I root 3 minus 1 on 2 root 2. So let's just move to the bottom there. Okay, so the next step now is we just equate real and imaginary parts. So what that means is that the cos pi on 12 would have to equal the 1 plus root 3 on 2, and the sine pi on 12 would have to equal the root 3 minus 1 on 2 root 2. So you can find cos pi on 12 exactly. 1 plus root 3 on 2 root 2, and the sine pi on 12 will equal root 3 minus 1 on 2 root 2. So that's that and this one. And then you have sine pi on 12 and cos pi on 12 in exact form. And it's using complex numbers and mod arg form. You could also do these by cos pi on 12, you could do it by also using trig expansions. But if you've got a hence, then you can't really, like if you've already found the other two parts and it says hence and it's kind of sitting there for you already. So pi on 12 is just 15 degrees. So you could also do it using an expansion on 45 minus 30, because that equals 15, and that's the same as cos A minus B, that expansion. And then finding each of the things, like so it's cos 45, cos 30, cos does a different sign, sine 45, sine 30, and then you figure that out, which is 1 on root 2 times root 3 on 2 plus 1 on root 2 times 1 on 2, which is root 3 plus 1 on 2 root 2, which you might notice is exactly the same as what we got up the top when we found cos pi on 12.